Assessment 4. This is the key. The quote is by Plato, who said, "I've hardly ever known a mathematician who was capable of reasoning." This is pretty funny to us, but maybe it's worth knowing that at that time, a mathematician was different than a mathematician today. I think mathematicians were more like astrologers at that time. There's a similar kind of funny quote by St. Augustine about mathematicians. So the warm-ups are I cross K. This is a repeat from the last assessment, and it's minus J. I dot K, these are perpendicular to each other, so the dot product is 0. And I dot I, these are in the same direction in both unit vectors, so the length is 1. Based on Plato's experience, based on the quote above, let's see, sorry, so here, reference to this quote. How good were mathematicians at thinking and reasoning? Answer using complete English sentences. Well, since he said he's hardly ever known one, presumably mathematicians were not very good at reasoning. Mathematicians were not good at reasoning. Period. And we should, since it's a sentence, we should probably start with a capital M. Question 2, find the equation of the tangent line to the cycloid x equals 3 theta minus sine theta and y equals 3 1 minus cosine theta at the point where theta equals pi over 3. And so we need to find dy d theta. So what do we need? We need a point, and we need a slope. So if we start by finding the point, this would be where x is equal to 3 times pi over 3 minus the sine of pi over 3. Sine of pi over 3 would be root 3 over 2. And y would equal 3 times 1 minus the cosine of pi over 3, that would be 1/2. Okay. So now we got to find the slope. So to find the slope, we need to find dy d theta, and we need to find dx d theta. So let's see. So dy d theta, I've covered it all up, would be, it looks like 3 derivative of cosine is negative sine, so so this would be 3 sine theta. And then the derivative of x with respect to theta would be 1. So this is dy d theta. And then dx d theta is 1 minus cosine theta. So together, these tell us that dy dx is equal to 3 sine theta over 1 minus cosine theta. And if we evaluate this at theta equals pi over 3, we're going to get 3 times root 3 over 2 divided by 1 minus 1/2, which would be 3 root 3 over 2 divided by 1/2. The 2 halves kill each other, leaving you with simply 3 root 3. Did I lose the other 3? I think I did. Let me just check something here. Oh, this should have been 3 minus 3 theta. So this would be 3 minus 3 theta multiplied by 3. And there, that 3 is going to cancel with the 3 above, leaving you with just square root of 3. So this is your slope. So we have a point, and we have the slope. And assuming we haven't made any arithmetic errors, that means we should be able to get our tangent line. The tangent line is going to be y minus the y value, should be minus 3 halves, equals the slope, root 3, times x minus, and then we've got that ugly bit for the x value. It looks like it's going to be pi minus 3 root 3 over 2. Something along those lines, where x value is showing up here, the y value is showing up here, and the slope is showing up there in our point slope form. So there is the equation of the tangent line to the cycloid. Question 3, use the calculus of parametric curves to derive the circumference of a circle with radius 1. To do this, first parameterize the unit circle, making sure to include limits of integration, then find the length of the curve. And really, this should be limits of integration. It should be limits of your parameter. So we're going to parameterize. And so we get that we're going to let x equal cosine t and y equal sine t. And this is all on 0 less than or equal to t, less than or equal to 2 pi. And then, so that was the first, step 1. And then it says 2, then find the length of the curve. So 2, L is going to be the integral from 0 to 2 pi of the square root of dx dt squared plus dy dt squared dt. So this would be the integral from 0 to 2 pi of the root dx dt would be negative sign. So I have minus sine squared plus derivative of sine would be cosine of t squared dt. The square is going to kill the negative, so this is going to be the integral from 0 to 2 pi of the square root of 1 dt. Square root of 1 is 1, and so we have the integral from 0 to 2 pi 1 dt, which is just simply 2 pi. Woohoo! We have verified the circumference of a circle with radius 1. Could have put an r in front and verified that the circumference of a circle with radius r is 2 pi r. Question 4, if r of t equals 1 plus t cubed, comma t e to the negative t, comma sine 2t, find the unit tangent vector at the point 1, 0, 1. So the first thing we'll do is we'll find the point. Or the point, or maybe I should say the time. So if our point is 1, 0, 1, it looks like based on that first coordinate that the t is going to have to be 0, and then we can check if t equals 0, the other two components are 0. We've discovered the time equals 0. So 2, we want to find r prime of t. So r prime of t is going to equal not 1, but just 3t squared, comma, here we have to use the product rule, so I have e to the minus t plus t e to the minus t, but it's going to be negative now because of the chain rule, comma, 2 sine 2 cosine 2t. And we get that r prime of 0, that's our time, is equal to 0, comma, looks like we have 1, comma, 2. So 3, we're going to find the magnitude of r prime of 0. We can evaluate here because we're not needing any subsequent derivatives. And so this is going to be the square root of 0 plus 1 plus 4, or square root of 5. And 4, we get that t of 0 is equal to 1 over root 5 times 0, 1, 2. And there you have our unit tangent vector at the point 1, 0, 0.